We're now live. Good afternoon, and thank you for joining the Ohio Valley Environmental Coalition for our presentation in partnership with 24 Hours of Reality Countdown to the Future, a weekend of conversations hosted by the Climate Reality Project happening worldwide. The Ohio Valley Environmental Coalition, also known as OVEC, is a 501c3 nonprofit grassroots organization based in Huntington, West Virginia, dedicated to the preservation of the environment and communities throughout West Virginia and the Ohio River Valley. Today, we are pleased to be joined by Dr. Randi Pokladnik, an expert in environmental science, who will be telling us about the science behind our changing world. Before we get started today, if you're with us on Zoom, we ask that you please mute your microphone for the duration of this presentation. There will be an opportunity to ask questions during a short Q&A immediately following the presentation, during which we invite you to unmute your microphone to address the speaker or use the chat function. Dr. Pokladnik, thank you for being with us today. And with that, I'll turn it over to you.
Hi, everyone. I'm glad you could show up today. It's pretty hectic right now with what's going on in the world. So anytime I can talk to people in this way, it makes it for a better situation. I'm trying to, my thing is, there you go. Okay, so a lot of people took chemistry in college and in high school. And one of the names you may have remembered was this person, Arrhenius. And one of the things that Arrhenius found out was back in the late 1800s, that fossil fuel combustion that created CO2 may be adding to the climate change scenario. And this was just when the Industrial Revolution was taking place. So it was really a great discovery that he made, and he did lots of experiments and found out that CO2 could absorb energy. On the 5th of November in 1965, climate scientists summarized the risks associated with rising carbon pollution in a report for Lyndon B. Johnson. And I was just 10 years old when that happened, but it just shows you how long ago that climate scientists were sounding the alarm that something was happening. This is not something that just happened overnight. This has been ongoing for over 50 years. Now, this is another graph or chart that you may remember from science class. This just shows you the electromagnetic spectrum. And when you step outside at any moment, you will get bombarded by the electromagnetic spectrum. Now, lucky for us, we have things in place in our atmosphere that keep us from getting bombarded with the high energy spectrum, which is on the left side of the graph. And this would be things that you would be exposed to if you walked into the Chernobyl area, or if you were up in an airplane above most of the atmosphere. This is one of the issues that people that fly in planes a lot, they get exposed to more electromagnetic spectrum radiation than somebody that doesn't fly. And then if you look at the right side of the chart, you'll see the bigger waves. And when I teach this, I tell students it's like the waves on the ocean. They're very slow, they're very large, they butt up against the shoreline, and they don't do a lot of damage. And these are slower and they don't penetrate the skin. Should you look at a microwave? No, because microwaves can still cause damage to the retinas, but these are completely different as far as damage as the left side, where you have the very small penetrating, almost like bullets getting shot into your skin. This shows you the different layers of atmospheres that surround the Earth. We live in the troposphere. This is where all our activity takes place. And one of the things I like to point out is if you look just above the label for the troposphere, you'll see the ozone layer. Now, the ozone layer, if you wanted to see how thick it is, just take a dry erase marker and draw a line. It's about 3 millimeters thick. So that ozone layer that was in trouble several years ago, that's the only thing that protects us from a lot of the incoming ultraviolet radiation. And this was a huge issue that all the nations of the world came together to address and successfully addressed it. And we know people that lived in, like, for instance, Australia, had a much higher rate of skin cancer, and it had accelerated every year. And most of this was due to the fact that we had placed our ozone layer at risk, and with the refrigerant created a hole in it. So the greenhouse effect closely mirrors what happens when you sit in your car with the windows rolled up. And the sunlight that shoots all this different various wavelengths of radiation comes through your glass windshield with a lot of energy, and then it kind of bings off of your upholstery and your car seats and your carpeting and anything that's in your interior of your car. So it's like when you shoot pool and you break and all those little balls hit against the sides of the pool table, and eventually they slow down and they lose energy. Well, this is what happens to your car. And because they lose energy, all that energy that comes into the windshield does not escape out of the other side of the windshield. So it stays for the most part inside of your car. And every minute it just keeps building up and building up and building up till you get really high energy and you get a lot of heat in your car. This is why so many babies and children and pets that get locked into vehicles or trucks die because of the heat building up. Within 10 minutes, it can be life-threatening. And this is what's happening to our planet. So think of the windshield like our atmosphere. Some of the energy of the sun reflects back, but most of it comes through that atmosphere, and then it hits on the soil, it hits on the ocean, on the polar ice caps, on the farms, anywhere that there's a surface area, it will hit. And sometimes it's absorbed and sometimes it bounces back. But what causes it to not bounce back as readily, instead of the upholstery, we have the greenhouse gases. So that little molecule that you see that's like red and gray, that's a greenhouse gas, could be CO2. And the structure geometrically, without explaining it in chemistry details, the structure enables certain molecules like CO2 and CH4 methane to be able to absorb the energy and prevent it from escaping back out into the atmosphere. So it's like a blanket. They hold that energy from the sun inside of that troposphere, and that just keeps heating up and heating up, much like the windshield of your car does. Now, a lot of people have argued about whether or not people agree. Well, the scientific community agrees that climate change is real, it's here, and it's man-made. And these flags represent the 80+ National Academies of Science that endorse the consensus. And if you look at the bottom, you'll see the United States down here. So the scientific community does agree about climate change. The problem with the United States is, there we go. The problem with the United States is the citizens don't necessarily agree. So the top of this chart says, to what extent do you agree or disagree? The climate change we are currently seeing is largely the result of human activity. And oddly, China has the most agreement among their citizens that were polled. The bottom of the developed nations, US and Great Britain. So you might wonder why that's the case. Unfortunately, that's the case because so much of what we know about climate change has been misrepresented in the media. And most of this is because the oil and gas industries, the coal industries have for years, behind closed doors, tried to put out a false narrative about climate change. And they tried to make it look like there wasn't scientific consensus when there was, and they try to make it look like it's not man-made when most of it is. This is a pretty famous chart called the hockey stick chart. This goes back 800,000 years. The 0 point on the right side of the chart represents 2020. And you can see, of course, the climate has fluctuated. The temperatures have fluctuated. The parts per million of CO2, which is on the left scale, those have fluctuated over time. And we know from studying evidence in nature, we've gone through several glaciation periods our planet has. I mean, at one time there were 7 miles of ice above where Toledo and Cleveland are, pressing down on the geography of the state. And that's why Ohio is so flat when you get up into that part of the state, and then it gets hillier as you get below Canton, Akron, and even further down towards Marietta. It's much more hilly. Now, I looked up the climate change data and tried to get the most accurate level of parts per million. As of this month, 411 parts per million on the right-hand side. In 2014, it was 400. The one thing that happened this year with COVID-19 and the close up of a lot of national economies was that we got a little breather. The planet got a little break from all of the pollution from fossil fuel burning and actually started to heal. But unfortunately, as soon as these economies opened up, people were back in their cars. They weren't carpooling. They were doing everything that they did previously. So that little breather period is probably just, lost now. We're probably actually above 411. Now, how do we know the information that we do to make that graph? Well, there are a lot of things that we can look at in nature. Obviously, we didn't have temperature readings much beyond the 1700s, but we do have tree rings, we do have ice cores, fossilized pollen, and ocean sediment. So scientists used all of these pieces of data to create that graph that you saw on the previous slide. I was fortunate enough several years ago to be able to visit the Byrd Polar Research Lab at Ohio State University. And this is where they store the cores of all the glaciers around the world. And unfortunately, they didn't get to every single glacier, but they have, it's like a library of cores. The one that you see that they're cutting, they have, it almost looks like a library because it looks like bookcase shelves, and it's, really cold. It's like a freezer when you go inside. And they have all these ice core samples from various glaciers around the world. It's really an interesting thing to see. And what they will do is they will saw down through the various layers of these ice cores. And of course, the deeper you go, the further in history that you're digging down into for data. And then when they take these little pieces of ice, they're able to unthaw them in a vacuum system. And then the little pop of atmospheric air, or little pieces of air from that climate many, many thousands of years ago, pops out of that little ice as it melts. And then they're able to take that and they look at the oxygen isotopes. So they look at all the climate change gases that could have been around in those time frames. And just to show you some of the different greenhouse gases and some of the issues with them, carbon dioxide is the one we hear about a lot. And I think that the thing with carbon dioxide is that, and I'll show you a reaction of that. Anytime you burn anything organic, if you burn sugar, and sugar's got carbon, hydrogen, and oxygen in it, you burn sugar, you release carbon dioxide. So any carbon-based fuel releases carbon dioxide. The problem with carbon dioxide in our atmosphere is that it can last for 300 to 1,000 years. It takes a really long time to sequester or collect that carbon dioxide. Of course, trees growing is a great way to do it, but there's only so many trees you can grow, and there's other ways you can sequester it. Unfortunately, our oceans are also pulling in a lot of CO2. Water is a climate change gas. Anybody that's gone outside on a humid day knows that it does collect the heat, but water in a few days dissipates, whether a rain event or wind blows it away. Nitrous oxide is another climate change gas. It's around for about 114 years. And then we have methane, which is short-lived. Now, the issue with methane is that it's really accelerated as far as atmospheric deposits, primarily due to fracking that's exploded, especially in the Ohio River Valley. And even though it only lasts 12 years, we know from climate scientists giving us the warning that we may only have a decade to get in front of this train wreck and try to slow it down. So right now, we are really focused on methane emissions as well as the CO2 emissions. This just is a little chart of telling you about the ice core samples. And as I mentioned before, if you remember chemistry class and you remember isotopes, isotopes are pretty much identical except the number of neutrons. So oxygen 16 is slightly less weight-wise than oxygen 18. And they will take these two isotopes of oxygen and they will compare them. And they're able to tell us about the global temperatures in the past. And another thing they can do with these ice cores, if you ever get a chance to see one, or you can actually Google and probably see this, there are places in the ice core samples where they have like a black line. And it's almost like when you go out in the snow after it's just fallen, and then you go out 3 days later and you'll see like dirt or soot on it. particulate matter has built up in these ice core samples over thousands of years. And they could even tell when there was a volcanic eruption. They'll say, well, look at this section is really dark. There's a lot of black, participle or particulate matter in there. And this is when there was probably a volcanic explosion deposited that ash. And they can use other instruments like gas chromatographs and mass spectrometers to identify pollen and maybe sources of where this ash came from. So the ice core samples are really important. This is a case of a picture speaking 1,000 words. This was a glacier back in 1941 and what it looked like in 2004. And it may even be worse now, but you can see that it's pretty much receded to just a tiny little piece of ice back by the mountain range. And here's another picture in 1977 and then in 2006. And obviously it's receded as well. I'm in trouble with my There we go. I don't know why that's giving me problems. Okay, this is a flaring operation where they burn off fugitive emissions of methane. And you can see these are a lot around oil and gas facilities. And it's wasting the gas for sure because you're just burning it off. And it creates a flare at night. If you're somebody that likes dark skies, you're not going to see them in this area. But right now we're, like I said, at 411 parts per million of CO2 and probably even higher than that. Now I got this out of an article in The Guardian, but this is from a research paper that was an internal publication within the Exxon scientific community. So scientists at Exxon had been studying the effect of CO2 emissions on our atmosphere long before this became a big deal. So in the 1980s, early 1980s, they published internally a report that shows how much the temperature will increase and how many parts per million there will be at various years. And if you look at that graph at the bottom where it has years and you go up, it just really is close to 2020, so maybe like 2018, and it intersects one of those black lines, the curved lines, with the temperature increases, and then go across to the left-hand side of the graph, and you will see the parts per million of CO2. So they were able to predict back in 1982 that around 420 parts per million of CO2 would give us, go on the very right-hand side, a 0.9 increase globally in centigrade of the world's temperatures, which is spot on. And that's how great they were able to, they were able to predict that climate change. So they knew exactly what was happening. They knew the increase in CO2 was going to cause a rise in global temperatures, and they sat on that data. Okay, I'm not going to go into each one of these indicators, but a lot of times when you talk to people that are climate deniers, they say, well, what about this? Well, what about that? Well, one of the things that I hear a lot is that they say the planet's warming up because the sun's getting more intense. Well, the easiest way to debunk that claim is as far as the atmosphere warming up, we have, like on the right-hand side of this chart, cooling stratosphere. So if you remember that diagram of the different layers of atmosphere, we live in the troposphere, and then we have the little ozone layer, and then just above that, we have the stratosphere. If the sun were more intense, then all the layers of the atmosphere would be warming up equally. But the stratosphere is in fact cooling, and it has cooled significantly in the last 50 years. So what's happened is, because we've generated so many CO2 molecules and we have trapped the heat in the troposphere layer, they are not able to escape the energy from the sun and warm up the stratosphere layer. So that totally debunks this idea that the sun is more intense or brighter, and therefore, that's why we're getting warmer down here, because our stratosphere would be increasing just the same as the troposphere did. Okay, another one, people talk about you know, record lows and record highs, which is really weather. But if you look at the overall picture of all the record lows and all the record highs, we have far surpassed the amount of record lows with our record highs. And every year we keep hitting new record highs on the planet in various places. I think Death Valley, I can't remember, it was 114 or 116, some ridiculous temperature, but Death Valley this year broke the record high for the planet. All right, another climate change myth that people like to talk about, especially when it comes to signing any agreements internationally, is that why should the United States cut back, let the other countries cut back? Well, in fact, the United States per capita emits more CO2 than any other nation. So we're just shy of 15 metric tons per person. And I put Africa's down there. I looked up Africa because it wasn't on this chart. Africa is 0.6, and the undeveloped nations of the world are significantly lower in the amount of CO2 they produce. Their lifestyles are different. They don't have cars. In some cases, they don't have refrigerators. They live in modest homes. They don't consume the way we do. So we have a lot of room to grow as far as reducing our footprint, do so that they don't carpool anymore. There's so many HUVs and trucks on the road that really, I see one person in them. Why is that, you know, the case that there's so few people that want to carpool or drive energy efficient vehicles? And there are things that, like I said, it saves the planet and it saves money too. This is just the combustion reaction. Like I said previously, anytime you burn a carbon fuel, whether it's hay, sugar, methane, coal, you're going to get CO2. You just can't get around that. You're going to make a climate change gas with any combustion of a carbon-based fuel. A lot of times we've heard that the renewables are really hurting the coal industry, and let's keep coal alive and go coal and cheer on coal. Well, coal is one of the dirtiest fuels as far as the amount of CO2 that you can burn. And coal didn't get killed by renewables. If you look at this chart, especially in the United States, coal got killed by gas. Natural gas almost parallels, you know, coal as far as when coal dips, the natural gas goes up. So you can see that natural gas has really been the reason that coal has dropped as far as using it for a power source. And the Ohio River Valley, the county that's just north of where I live, Carroll County in Ohio, they're building 2 gas-powered plants. And then the county I live in, Harrison County, is building one close to the county seat, Caddis. There are a lot of new gas power plants coming online. This doesn't have anything to do with renewables. I wish that it was renewables that were killing coal and gas, but that's not the case. Just another picture of a industry. Just for a few minutes, let's talk about fracking. And this exploded on the scene around 2010 in my area. And every process that you go through, from the well pad to the well to sending it to a natural gas facility, fracking has so many places where methane and other chemicals, fracking chemicals, can leak into the environment. It's just full of externalities that people try to overlook in the industry. But the bottom line is that since we have started fracking, especially in the United States, scientists know that the methane in the atmosphere has increased significantly. And we know there are leaks. Everywhere along pipelines, there can be leaks. In the drilling operation, there can be leaks. There are all kinds of places where we can get leakage of methane gas from fracking. One example of a really big leak was in 2018 in Belmont County, which is one county away from where I live. 60,000 tons of methane leaked out in 20 days in a blowout of a well. The XTO well was in Belmont County, and there was an accident, and it was in the wintertime, and this well experienced a blowout, and for 20 days it just spewed toxic compounds, including methane, into the air and the surrounding area around that. People, evacuated, but I don't think they evacuated nearly as big an area as they should have. But this is just one case. They said that that blowout was equivalent to the annual emissions of methane from some countries in Europe. That's how big of a plug of methane went into the atmosphere from this well blowout. Right. Sadly, our politicians, for the most part, and the fossil fuel industry has big plans for the Ohio River Valley. They want us to be the next Cancer Alley. They want us to take up where Louisiana left off, and they want to build cracker plants, at least 5, all up and down the Ohio River. They want to increase fracking. They want to make single-use plastics, which we know from so many news and documentary programs that we are drowning in plastics. Our planet is literally covered in plastic. It's in the air, the rainwater, beer, drinking water, food, the ocean, the deepest depths have plastic fibers. It's in fish, pretty much everywhere. You can't escape it. And they say everybody eats the equivalent of a credit card's worth of plastic, whether you're ingesting it in your food, your air, or your water. Everybody eats a credit card of plastic, or breathe credit card worth of plastic in a week. And plastics have all kinds of toxic materials in them. They're not benign by any stretch of the imagination. Now, I mentioned in the previous slide about the various stages of fracking, and this is just a list of some of the things that go on. And the entire life cycle of plastics to get the ethane gas from fracking to make the polyethylene is just riddled with externalities from extraction, distillation, forming it into products, transportation. They make tiny little particles. They look like BBs almost, even smaller. They're called nurdles, and these are what companies buy to make their plastic products. And then if you dump it into a landfill, plastics really don't biodegrade. Even the ones that say they're biodegradable, they have to be raised to a certain temperature for a certain amount of time. They just don't break down. We're talking about, hundreds of years that plastic bottle is still going to be around. Incinerating is not the answer because that creates products of incomplete combustion. Recycling, we recycle 9%. In 50 years of trying to recycle, that's as good as it gets in the United States. And as I mentioned before, composting doesn't work either with plastics, especially ones that aren't deemed to be compostable. They just don't break down. They break into pieces, but they don't break down. I found this quote, and I can't find the person who said it, but I read it in an article. The best plastic is the plastic never made. And that's true. And we really have to rethink our lifestyle and what we do as a country and as the world population. When we see what this is doing to not only the humans as far as health effects, but what it's doing to the ecosystems around the world, where albatross chicks are being fed pieces of plastic and they're dying because they're starving to death, or whales are ingesting huge amounts of plastic and dying, and rings around turtlenecks, and the plastic fishing net in the ocean that's trapping dolphins. I mean, there's just no end to the amount of damage that throwaway plastic has created for the planet. All right, so now let's talk a little bit more about the effects of climate change. We know that it affects human health. We've seen heat stress in countries that can't afford air conditioning. We know that diseases are worse in areas where there's more heat. Pathogens seem to thrive in hotter areas. As far as ecosystems go, we've lost a lot of the aquatic habitat around the world, and then pests that are normally killed by very cold winters are no longer killed by those cold winters. I use the example of ticks in Ohio. When I was a kid, there were very few ticks around, maybe on our dog once in a while, but now we can't go outside, especially now, and come back in the house without at least having one tick on us. And this is probably due to the fact that a lot of our winters do not get cold like they used to when I was a kid back in the 60s, when we had lots of snow and it got really cold. These pests are able to survive through some of these winter seasons that are very mild. Another thing to talk about is the ocean acidification. The oceans make up 3/4 of the surface area, and all that CO2 that's in the atmosphere is being absorbed by the oceans. This is causing reef bleaching, especially in the Australian continent where the reefs around that area are pretty much dead. And then if you look at economic impacts in society in general and national security, these are going to cost astronomical amounts of money due to the effects of climate change. Yet the politicians refuse to acknowledge that fact. One of the things that's going to be worse are summers. And if we let this go, we're going to have unbearably hot summers, especially in places like Texas, Louisiana, Mississippi, where pretty much the entire summer season is going to be monopolized with days above 100 degrees. And even in the Midwest regions like Ohio and Illinois and Indiana, we're going to have more days above 100 degrees. I kept track of the days in Ohio where I live, and we had over 25 days that hit 90 degrees this year, which is definitely not normal and has significantly increased. Another thing that scientists have noticed, especially people who look at bird species, which are in dramatic decline, if you look at the left side of this diagram, you'll see that in the 1980s, our bird babies hatched, our hatchlings were around at the same time that our insect populations were peaking. So there's plenty of food for mom and dad to feed the baby birds. Then if you look at today, the peak mass of the insects hatching and caterpillars happens 2 weeks before the babies hatch. It happens around May 15th instead of May 28th. So by the time the babies are in full swing and trying to get nourishment, the parents can't find enough insects and caterpillars to feed to them. Sir David Attenborough talks about what's happened to the Great Barrier Reef in a lot of his documentaries, and he says this is a call to arms, that we really need to think about this as a battle that we need to fight to save the planet, and especially the oceans. Anybody that has relatives in California or has watched the news knows what's happening in California right now. The most amount of acres ever have burned, 4 million acres. The 2018 season in California was especially bad as far as in human lives, people that died in the fires out there. So the region along California and some of the other western states have just been on fire since the summer started. Venice had the highest tide in 50 years this year. So we see catastrophic rain events along with fire events. What happens with our oceans? We've talked about acidity. They become more acidic because they absorb CO2. Warm water expands, cold water contracts. So as we warm up the oceans, we get thermal expansion. Then we have the melting from ice sheets in Greenland and on the North and South poles. Storm surges are worse. We know from some of the storms recently that the Gulf region gets hit with more catastrophic storms than ever. It's increasing every year, and this year's no exception. And this is a sobering fact. In the past 150 years, the amount of heat that the oceans have absorbed is the equivalent to the amount of heat energy from 1 atomic bomb blast per second. And you don't think about it that much because the ocean doesn't seem that warm to you. But if you go into the ocean and you think about how much energy and how big they are, this is a lot of heat energy that you can warm up the oceans equivalent to 1 atomic bomb blast per second. This graph just shows some of the information about ocean acidity, and we all remember pH from taking high school science and high school chemistry, but the pH of the ocean is definitely dropping where it used to be basic, so above 8, it's now below 8. And even small decreases, because the pH scale is an exponential scale, makes a big difference to ocean life. Because remember, the organisms in most cases have the carbonate shells on them. And if you take a seashell and you put it in vinegar and you see that effervescence, that means you're pretty much breaking down the carbonate ions and you're creating CO2 gas, and you're destroying those shells of those ocean creatures. They're thinning and they're more susceptible to pressure now. Another economic factor that we can look at as far as the United States is the western areas, which boom with the winter sports, snowboarding and skiing. They're noticing a definite decrease in the snow and a drop in the amount of tourism that comes into their area. So this is costing a lot of local communities in those regions a lot of money. And then farmers can talk about crop yields. In 2019, especially in the county where I live, we had the wettest spring since 1895. And the farmers just gave up. I mean, most of the area where you would drive by and see corn planted or soybeans, they just didn't plant it. They couldn't get into the fields. And when you do have higher temperatures, it does affect the yield. So you can see the corn yield drops in higher temperatures. It increases towards 6 degrees. And the same thing with soybeans. The yields on the soybeans decrease as well. Okay, military bases. Anybody in the military can tell you that they have issues with the coastal bases. I have a nephew who is in the Navy, and he said, you know, sometimes they just have to take the subs, you know, further out into the ocean because of the flooding and then the storm surge, especially in the Gulf region where they have bases. Okay, the albedo effect is something that's causing a positive feedback loop. With the planet, I think of the polar ice caps as like the planet's sunglasses or mirrors that reflect incoming sunlight. So as long as we have ice cover in those regions, we reflect sunlight, so like wearing a white t-shirt versus a black t-shirt, and it bounces off of those areas where there's a lot of ice. Once we melt that, then we expose soil and vegetation, which does not bounce sunlight off. It absorbs sunlight. So the more ice we melt, the hotter it gets. The hotter it gets, the more ice we melt. And it's just like a snowball rolling down the hill. This is what's meant by a positive feedback loop. And this just shows you how much of the polar ice that we have lost over decades. And in some cases, there's open ocean in the North Pole. And a lot of people in industry are just rubbing their greedy little hands together because they can get at places that they couldn't get at before with the ice in place. Now they are talking about more mining and more oil drilling in the North Pole area. This is something that happens when you melt the areas up around the North Pole and in Siberia where they have tundra that has been frozen for millions of years. There are methane deposits that occur as methane hydrate, so it's little bubbles of methane that are trapped in the ice. Once that ice melts, they release that methane gas. And scientists are really worried about the melting areas around the North Pole because this methane gas could really accelerate climate change. And this is just a slide that shows you, you know, how it bubbles up as the land gets unthawed and that trapped methane is finally released into the atmosphere. Most people that took biology remember the carbon cycle, and I don't want to go in depth in explaining this, but obviously there's carbon sinks and there's carbon sources. And the problem with what's happening now with our planet is that we are destroying the sinks, like the Amazon rainforest, and we're increasing the sources. So it's out of balance. Instead of cycling through and maintaining a balance, we have a lot more carbon in the atmosphere from the carbon dioxide of burning fossil fuels and slash and burn that's killing the rainforests and other forested areas. And then we have the water of the ocean and other areas where water is absorbing CO2. And there's only so much. It's just, you know, like Pepsi. When you take the cap off your Pepsi bottle, your carbonation goes into the atmosphere. There's only so much that, you know, these bodies of water and these forests can absorb until, you know, most of the CO2 is going to end up in the atmosphere and in the ocean itself and acidify it. This shows an aerial photograph of what's happening to Greenland. They said that the last time that area of Greenland that melts was that bad was in 1889 when large forest fires deposited a layer of soot on the ice. And I guess the thing with Greenland right now, and this was taken in July this year of 2020, and they said in one day 34% melted, but all that, the fires that are burning, all that particulate matter gets into the upper atmosphere, and it doesn't just stay over California, the western states. It gets in the jet stream, and eventually it gets deposited on areas where there are ice and snow. And the black on the ice and snow attracts the sunlight or the energy from the sun, just like your black t-shirt would. And this causes the ice and the snow to melt even faster. So the forest fires are actually impacting the ice areas of the planet and causing more melt because of the dark color of the particulate matter. And of course, the Siberian area of Russia hit record highs this year. It was 84 degrees near the Arctic Ocean, and this is not normal. So some solutions before we end. There are a lot of solutions. The solutions are out there. It's you know, the fact is, do we have the political will to mobilize and fight this? It's just as if we were fighting a war, because it is a war. It's a war for the planet, a livable planet for our kids and our grandkids to inhabit. We know wind is one of the factors, solar energy, geothermal, reducing the use of petrochemical products such as plastics. 40% are single use and throwaway, and is that really worth it to use precious fossil fuel resources that maybe 7 generations out might need to make a plastic wrapper for your sandwich? Buying less of everything. Think about everything you buy and all the energy that was used to get that product to your home. Don't waste foods. Grow local or buy, you know, from a local grower. Population control. We have to find a way to curb that. Adopt a vegan diet, because we know meat contributes a lot to climate change. And energy efficiency. Just one case is LED bulbs. And if you want some other ideas, the book Drawdown has many, many great ideas and talks about some of the things that we can do to curb climate change. And 3 of the top 10 have to deal with food. Here's just a picture of one source of energy using wind. This was in Iowa. And we know wind power is just exploding in Texas and some of those wind corridor states, North Dakota, South Dakota. And Ohio and West Virginia could also be states with significant wind power. This is a map showing some of the wind power in the area. And, you know, we know that West Virginia's got, we've seen the wind turbines, they've got them, you know, on the hillside. And especially in the Great Lakes region, there's a lot of wind capability around the lakes, especially around Lake Erie and the Cleveland area. There were plans to build some experimental wind turbines up there that have kind of been put on hold with the political climate in the state of Ohio, which is anti-renewable energy. This is a picture of my house. My husband and I built a log home, and then when we had our garage built, we decided to finally put solar panels on that we've wanted for years, and it was very affordable, and we used a local company to put them on. And if you're thinking about maybe going meatless just once a week, it's going to make a difference. The bottom of this chart shows that by far the meat sources are the highest for producing CO2. The top of the chart, which is green, shows the plant-based food choices are the best for climate change. And then we mentioned food waste. That's definitely a huge deal, because everything that happens to get your food from the grower to your table has some carbon footprint with it, unless you grow it in your backyard. And then to end with the hero of climate change is Greta. She's done more to educate the planet than anybody I can think of, and it's her planet that she's going to inherit. And just like so many young people, the older people like me and some of the people in the audience, we need to step up, because you know, we enjoyed our day in the sun, and now we're going to pass on a very damaged planet to this generation that's coming up. Thank you for listening. Hope you learned something, and hope you do something to stop climate change.
Thank you so much, Dr. Pokladnik, for such an informative and interesting presentation. We did have a few questions from participants and viewers in our audience. One question was, what is the role of nuclear power as a solution to climate change?
Well, I was born during the nuclear age, when we did drills, when they thought maybe we'd get bombed with a nuclear bomb. And a lot of people think that that's the answer, but you know, nuclear is not a magic or a silver bullet for climate change. I think just the issues of what happened to Chernobyl and 3 Mile Island, and finding out that 3 Mile Island was much worse than initially it was, you know, purported to be. And then there's the issue of nuclear waste. You know, who wants the nuclear waste stored in their backyard? Nobody, because it's radioactive for thousands of years. So I think rather than keep putting our eggs in that basket, we have the capability and technology to do renewable energy. I think we really need to move towards renewable and not, you know, make nuclear the best choice for replacing fossil fuels.
Thank you so much. And one other question that came up from folks was that according to the Yale program on climate change communication, a minority of people in our region, specifically West Virginia and Ohio, and perhaps even Americans at large, a minority of people believe that they will be personally impacted by the effects of climate change. Can you tell us a little bit about what we may be experiencing in our region if we do not get a handle on global emissions?
Well, I think we are already experiencing some issues with climate change. I'm from Ohio, and I took a course at the Ohio State Water Academy. And one of the things that they talked about watersheds and other issues, but they mentioned the fact that Ohio is seeing an impact from infrequent rain events. And when we do have rain events, they're very intense. And, you know, I'm old enough to remember when I was a kid, we'd have summer storms, and you know, the weather would clear up and it would be fine. You could go out and play. And we'd have, you know, maybe 2 a week. Now we have a 2-month, we had in our area in Harrison County, a 2-month stretch of absolutely no rain at all through July and August, which is really unheard of. And then when we do get rain, we have high winds and really intense rain where we get flooding events. And I have friends in West Virginia, and they've said the same. You know, there's a lot more flooding type rain events in West Virginia. So we know it has changed the climate in Ohio. As I mentioned, 2019 was the wettest spring, you know, on record as far as, you know, trying to get corn and soybeans in. So it has affected our climate, and I think it's affected the amount of pests as far as insect pests go. I think it's affected the soil to a certain degree, and for sure it's affected, you know, the Great Lake region with absorbing some of the CO2 from the atmosphere. So it's not as pronounced an effect as it is maybe in the polar regions where the temperatures have really gone up and skyrocketed, but definitely it has affected us. And will we see more effects if we don't get on board with doing something specifically to address this? I think we will see more effects. I mean, Ohio may be a place where people from Mississippi and Texas move to, so we will get an influx of, you know, climate refugees, you know, in the years to come from other states that just can't handle the intense heat, like Texas with, you know, 50 plus 100-degree days. So it may affect us in ways that we don't even think about.
I think we wholeheartedly agree at OVEC that it's an incredibly concerning issue. And thank you so much for elucidating some of that evidence that we are experiencing in our everyday lives presently. It appears that we have one last question. And in your presentation, you mentioned something called ASH, or the Appalachian Storage Hub. Could you elaborate a little bit more on what that is and how it relates to fracking and whether or not it will greatly contribute to methane emissions?
Well, it's going to greatly contribute to methane emissions because the Appalachian Storage Hub is kind of a group of projects, but one of the main things that they want to do is develop a series of cracker plants along the Ohio River Valley. And in order to feed those cracker plants the ethane that they need to make the polyethylene, they will need a storage facility. And the Mountaineer Storage Facility is one that they have proposed, where they drill down into salt deposits and create these huge caverns where they can store wet gas and dry gas, and then they can bring this up and feed the cracker plants with this. But as long as we're involved in any kind of fracking related activities, whether it's to make plastics or it's to get methane to send, you know, out of the country as a fuel source, there are fugitive emissions. And unfortunately, a lot of the regulations that were meant to cap some of these fugitive emissions and make the industry more responsible for methane leaks all along the process, those have been rolled back. So the industry has pretty much been given a free ride to put as many leaks of methane in whatever areas that it's leaking from, whether it's pipelines or the actual well pads themselves. They're leaking methane into the atmosphere and they're not being responsible for it. So it's going to keep feeding the methane gas explosion as far as the shale gas activities in the United States. And, you know, there is now a satellite up in space that can detect the increases in atmospheric methane. And this satellite picked up the well pad blowout in the XTO well pad in Belmont County last, what was December of 2018.
Thank you so much, Dr. Pokladnik. Is there anything else that you would like to share with our viewers before we wrap up for today?
Well, I like to think of climate change is like a goal that we can stop it, that we have the capability of doing that. And people will just get frustrated and just say, well, there's nothing I can do, I'm just going to give up. But there's so many things that you can do. And in the long run, truthfully, if you really did an audit of your home, you would cut back on your energy bills. If you just turned down your thermostat, if you wore a sweater like Mr. Rogers used to do, if you didn't use your air conditioning, opened your windows instead, you will save money. If you bought a hybrid vehicle, or if you carpooled with somebody, there's so many places where, you know, saving the environment from more fossil fuel emissions is actually going to save an ordinary household lots of money. I mean, hanging clothes outside. And if you look at how much energy a dryer uses, or you know, turning down the hot water tank, or turning down the hot water on your washer, using only cold water. I do that. Using cooler water in your dishwasher. There's so many places where you can cut back on energy use that will save you money and will also save the planet. So we can address this. We can become more energy efficient. And unfortunately, Ohio's with HB6 has destroyed that ability, because we've cut out our efficiency standards for our state right now. Hopefully that will get repealed, but we'll see.
Well, I would like to thank you again, personally, on behalf of the Ohio Valley Environmental Coalition. Dr. Pokladnik, we thank you so much for your time and your expertise. We're very grateful to have you with us today. For our viewers, again, if you would like to learn more about OVEC, you can visit our website at www.ohvec.org. Thank you all so much, and take care, and remember to take action.